Determine and sketch the spectrum of the DSB-SC signal 2m of t equals 4000 phi t for the following message signals. Here we have two parts. The A part I did in my previous video. If you watch my previous video, you will see this. And in this video, I'm just gonna take care of the B part. Okay. In the B part, the given message signal is m of t, that is equal to 40 over t square minus 40 plus 20. Okay, so this is what we have here, and then in order to do this problem, we have to do the Fourier transform of this one. Let's go ahead and do the Fourier transform. In Fourier transform, instead of writing like this, if we write this one in terms of perfect square, then it's easier to do the Fourier transform. So if I bring this one into perfect square, this is going to be 40 over. When I add, I have to get 4, and when I multiply, I have to get plus 20. So this is minus 4 and plus 20. Let's see some numbers that will work out here. Or you can do this one as well. T minus 2 t square minus 4 40. If I take t common, that's t minus 4 or you can write like this one as well. We can make the denominator perfect square by doing this 4 square plus t minus 2 square. Okay, so that will make t square plus 2 and t square minus 2, I mean t plus 2, t minus 2, and if you multiply this one, you will get this one back. Okay, so that way we can do the perfect square for this, and once we do that, then we can we can try to find the Fourier transform of this one, that is 40 over 4 square plus t square. And in Fourier transform, we have a property that if we have e power minus a t in the time domain, the Fourier transform of this one is 2a by a square plus omega square. So this is time domain to frequency domain, and this is duality property, like you can do the opposite as well. In our case, the one we have here, it's similar to this pattern here, so we can bring to this e power something by doing using the duality property. So we can mention that one here. So by duality property, two a over a square plus t square, that's the pattern we have right here. And that one, the Fourier transform of this one become, when we transfer from time domain to time domain to frequency domain, when we are using duality property, there will be a 2 phi will be multiply. Okay, and then the other things will be the same, e power minus, in this case, omega. Okay, so if we have this, then now we have to just go ahead and plug the values we have. So what we have here is 40, and in the denominator we have 4 square and then t square, 4 square plus t square. So from this one we know that a is 4, so the Fourier transform here is going to be 2 phi e power minus, instead of a we plug 4 here, and then omega. Okay, let's go to the next page. And that one is equivalent to that is that, but we are neglecting one thing, that is, you see on the top part we have 2 times a, that is the 40 here. So this one is basically, so if a is 4, then what value if I multiply by 2 gives me 4? That is 50. Not 50, 25. 25 multiplied by, no, I have to get 40, so 10 basically. So okay, a is 40, 2 times a. Okay, I just confusing myself. So this is just 8 here, and then that one multiplied by some value, that is 5 here. 5 times 8 is 5 times 8 is 2a. I mean 8 is 2a. So 5 is a constant, multiply. So that same thing is gonna happen here as well. So here also we have to multiply by 5. Okay. And if you do that, then this one become 10 phi e power minus 4 omega. So this is what we derive at the end, and instead of omega you can put 2 phi f as well, because omega is equal to 2 phi f. If you do that, then let's look at the next page. So m of f becomes 10 phi e power minus, here we have minus 4 right now. If you multiply this one by 2 phi f, then this is gonna be minus 2 times 4, 2 times 4, that is minus 8. 2 times minus 4, that is minus 8. Phi times f, minus 8 phi times f. Okay, so this is what we have, and it doesn't even necessary to do the conversion, but it's okay. This is what we have. And then once we have done that, now we can go ahead and draw the graph. So initially the graph is gonna look like this. It's gonna be centered in the origin, and the height is 10 phi because of this amplitude, and this one is m of f, and this one is in the frequency domain. Okay, now once we are determine the spectrum DSB-SC signal, 2m of t cos 4000 phi t, here we have to apply this one. So if we apply this DSB-SC signal, then it's going to be doubled right now, and the center is going to be whatever the frequency we have here. So here we have 4000 phi. If I write this one in terms of 2 phi f, this is going to be 2 times 20,000 phi t. So 2 phi times f, that is 20,000 t. Let's write this one again. 2 m of t cos 4000 phi t, and you know, like when we have a DSB-SC signal, that is contains a m of t and c of t, and if I remove this m of t part, then the rest will be c of t. In this case, that is 2 cos 4000 phi t, which you can write as 2 cos 2 phi times 20,000 t as well. Actually 2000. 2000 T as well. Then if that is the case, then this value is the FC. Okay, carrier signal carrier frequency. So FC is 2000 Hertz. Since FC is 2000 Hertz, then the split center is going to be located at 2000 left and right, because when you do the Fourier transform of this one, it's gonna shift it based on the cutoff frequency. Like for example, for this signal, if you do the Fourier transform, it's going to end up with the DSB-SC spectrum. It's going to be just a shift of cutoff frequency, so I mean carrier frequency, that is M of F minus FC, and then plus M of F plus FC. So you see that it's going to be shifted right and left by 2000. So this is going to be the same diagram, but it is right now centered at 2000 left and right. And the height is still 10 phi. And this is 2000, and this one is negative 2000, and this one is positive 2000, and this one also, the height is 10 phi. Okay, exact same diagram became doubled, and the center of the diagram is gonna be at wherever the carrier frequency is, that is 2000 from the left and right. Okay, and that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.